For those of you that are in Math 038, this is section R11. For those of you that are in 052 or 053, this is going to be a big chunk of section 2.2. And sorry. And then this is a big hefty portion as well of Math 025. And of course, if you're in Math 026, this is all stuff that you need to do on a regular basis. So we're going to start by just wrapping our mind around the idea of adding fractions, and the easiest way to do that is always by talking about pizza. So here we have a pizza that you and I have bought, and we have cut into 8 slices, and then I'm going to eat 3 of those because I'm hungry, and so I have eaten 3/8 of a pizza, and you're going to eat 2 of them. You have eaten 2/8 of the pizza, and the question is, how much pizza have we eaten together? And it's pretty obvious, I think, from the diagram that we have eaten 5/8, right, of the pizza. So that means that 3/8 plus 2/8, adding together how much I ate and how much you ate, gives us 5/8. Now, what I want you to notice is that look at those bottoms, they're all 8. We have not eaten 5/16 of the pizza. In other words, we do not add the tops and add the bottoms when we add fractions. We don't go 3 plus 2 is 5 and 8 plus 8 is 16, because look at the picture, we haven't eaten 5/16 of a pizza. We have eaten 5/8 of a pizza. I ate 3 of them and you ate 2 of them, so that's a total of 5/8 of the pizza eaten. So the first thing we notice is that for adding fractions, we do not add the bottoms. In fact, more than that, the bottoms have to be the same, because if I had eaten 3/8 of a pizza and you had eaten 2/14 of a pizza, how do you put that together? We'd have to, well, we're going to get there by the end of the lesson, but for now, there would be no way to do that. So the denominators have to match in order to add or subtract fractions. And that's what this says here. The denominators must match. And then we just add the numerators, or vice versa for subtraction, we subtract the numerators. So here's a couple really simple examples. You'll see that in all 3 of these, the denominators already do match. And we can think about all of these in terms of pizza. We've cut our pizza here into 12 pieces. I ate 5 of them and you ate 3 of them. How much pizza did we eat together? We ate 8/12 of the pizza. 5/12 plus 3/12 is 8/12. And of course, we always reduce our answers. So we notice that the top and the bottom here both divide by 2. You might notice at first. So we do that. That's 4/6. Oh, they're both still even. They both divide by 2 again. There we go. We've eaten 2/3 of the pizza. And if we showed a little picture there, we would see that 8/12 of the pizza, you cut your pizza into 12 and eat 8 pieces, is equal to as if you had cut the pizza into 3 and eaten 2 of them. Next one, we're doing some subtraction. Again, we've made it so the denominators already match. We could think about this even in terms of pizza. We had 9/10 of the pizza left. We had a pizza cut into 10. 1 piece was already gone. We have 9/10 of a pizza in the fridge. You sneak in and eat 5 of my pieces of pizza, 5/10 of the pizza. What is left now in the fridge? 4/10. But we always reduce our answer. 4/10, both divide by 2. We get 2/5. And by the way, over here, whenever we do multi-step reducing, divide by 2, we divide by 2 again. Whenever we do that, it means we could have done it in one step. So if you had noticed that 8 and 12 both divide by 4, then we would have gotten straight to that 2/3. But you don't need to find that best number. You can do it in stages and it works just fine. I usually find it easier to go bit by bit, unless I notice, oh, hey, I know that 12 goes into both those, and then I can save some time. Last one, again, we're adding, and we already have the denominators matching, so we're good to go with some adding. 11/16 plus 9/16 is 20/16. That's more than a full pizza. That's okay. That just means we bought 2 pizzas and we cut them into 16 pieces each. I ate 11 of my pieces and you ate 9 of your pieces. So how much pizza have we eaten in total? We've eaten 20/16 of a pizza. We notice that 20 and 16 both divide by 4. And we get our answer 5/4. Read the question whenever you get an improper fraction for an answer. Read the question. Do they say they want an improper fraction, or do they say they want a mixed number? Or do they say nothing, in which case either one is acceptable? And again, if you didn't happen to notice the 4, you could have divided by 2, and then you would have noticed they're both still even. Divide by 2 again, and you would get to the same answer. Okay, so those are nice and easy when the denominators already match. Mixed, right? So if we have mixed numbers, we have a couple different ways we can go. So here we got 3 1/15 plus 5 1/15. Option number 1 is we can turn everything into improper fractions and do it like we did on the page before. So let's do that first. We go 3 times 15 is 45, plus 1 is 46. And here 5 times 15 is 75, plus 9 is 84. And again, if you're in a section of your course where you have to do the tests without a calculator, having a printed out times table, see if you can find yourself a 25 or 30 times table and print it out. It saves a ton of time doing long multiplications and stuff. So here we have turned both of these into mixed fractions, as we learned to do last week. And now we're going to add those together. You might have to go off the side of your paper to add 46 and 84, carry the 1, and so on. You will come up with 130/15. And we always reduce our answer. So I think that those both divide by 5 for sure. So I'm going to do that. You might need to do some long division here. 130 divided by 5. You might be if you're good with your numbers, you might be able to brain that one out. If not, long division it is. Either way, you will get 26/3 when you do those divisions, which is the improper fraction option, or 3 goes into 26 8 times with 2 left over. So 8 2/3 would be the mixed number. So there's option 1. It's pretty good. Maybe the only downside was running into this big reduction here, having to do 130 divided by 5, having to add 86 and 4. The numbers got a bit big and they could get bigger. So let's look at this other option over here, option number 2. What I'm going to do is I'm going to pull apart the whole numbers and the fractions from each of these things we're adding. So we're adding 3 1/15 and 5 9/15. You see in red, I've pulled out just the whole numbers. And in blue, I pulled out just the fractions, because 3 and this, you could essentially read this as 3 and 1/15 and 5 and 9/15. So you're adding all of those together essentially. So 3 plus 5 is pretty easy. That's 8. 1/15 plus 9/15 is pretty easy. That's 10/15 because the denominators match in this case. We always reduce our fractions, so divide top and bottom there by 5. Much easier divisions. 10 divided by 5 is 2. 15 divided by 5 is 3. And now you just put together your answer. We got an 8 from the whole numbers, and we got 2/3 from the fractions. And there you notice, look at that, it is the same answer as we came to before, right? Or in this case, you might need to turn it into an improper fraction if that's what the question wants. So 8 times 3 is 24, plus 2 is 26, makes the improper fraction. So there's your two options. I would say the second one in this case was easier, but that's not always going to be true. And we're going to look in a second here. There is a little bit of a twist that you can run into sometimes when you do it by the option 2 method. So we'll want to make sure we're aware of that. And when you're subtracting fractions, option 2 will sometimes lead to a situation that's quite a bit more involved. That's the very last thing we're going to do today. I would say when you're subtracting fractions, mixed numbers like this, probably easier just to go all improper fractions unless you're really strong on noticing when it's going to be a problem and when it's not. So here's one for you to try. 9 3/4 minus 5 1/4. I know now I just said when you're subtracting, do it the other way, but I'm going to suggest you try this with the new method because I know this one works out okay. So I would suggest take the 9 minus the 5 and the 3/4 minus the 1/4. Give you a second to try that if you want to, and write out what this is going to work out to be. Okay, so I'm going to do both options, it turns out. So here's turning them all into improper fractions. 9 times 4 is 36, plus 3 is 39, so there we got the 39. 5 times 4 is 20, plus 1 is 21. And now I just subtract the tops, and I get 18. The bottom stays the same. 39/4 minus 21/4 is 18/4. Those both divide by 2, so we get an answer of 9/2. Or as a mixed number, 2 goes into 9 4 times, with 1 left over, 4.5 as a mixed number. Let's try option 2. I'm going to break apart the whole numbers 9 and 5 in red, and the fractions 3/4 and 1/4 in blue. 9 minus 5 is easy, that's 4. 3/4 minus 1/4 is pretty easy too, that's 2/4. Reduce the fraction. Oops, there we go. 2/4 reduces to 1/2, so I have 4.5. Again, you can see I got the same answer by both methods. Or if I have to turn that into an improper fraction, 4 times 2 is 8, plus 1 is 9. And there is the two options. It's kind of interesting. You notice in this method, we get the improper fraction answer and have to convert to a mixed number if that's what they want. In this option, we get the mixed number answer and convert to improper fraction if that's what they want. Okay, there is one twist, as I mentioned. So if this fraction over here, let's go back a few, more than I realized. There. If this number over here, we got 2/3 this time. If that happens to be an improper fraction where the top is bigger than the bottom, then there's a few more steps at the very end. So here we go. We're going to add 6 5/7 plus 9 4/7. Break them apart in red and blue. The whole numbers I put in red, 6 plus 9, and then the fractions in blue, we'll do those separately. Everything seems fine so far. 6 plus 9 is 15, no problem. 5/7 plus 4/7 is 5 plus 4 is 9/7, stays the same. And now you see we do have this problem because we would never say the answer is 15 and 9/7. That's not how we would express an answer because 9 is bigger than 7. So we have to take that 9/7, turn it into a mixed number. 7 goes into 9 once with 2 left over. So this is 1 2/7. Now what I can do is I can take that 1, combine it with the 15. That's now a part of the whole number, right? So I'm going to take the 15 and the 1, make them 16, and the 2/7 behind. So that's really not too bad when that happens. You just need to take this result you got here, turn it into a mixed number, combine the whole number with the whole number you already have. So with the adding, that's not too bad. When that happens with subtracting, you actually have to do some borrowing, and it gets this is what I was saying before, probably not worth it, probably easier in that case just to put everything into an improper fraction. But with the adding, not too bad. Okay. Oh yeah, so very quickly, this is more really for the 05 level students. This is the kind of thing you're going to start to see, that it does not bother us. We can still follow these same rules even if we start sticking letters in there, right? This is going to happen more and more in the 05-2, 05-3, 07 streams of math. So here in this first one, I can see the bottoms match. They're both 3. So I'm going to go m plus 2. Just like before, if that m was a 5, I would have gone 5 plus 2, right? It's an m, so I'm going to go m plus 2. What's m plus 2? Well, it's just m plus 2. Whoops. And we can't go any further than that because we don't know what m is. But you can see that we followed the same rule. We added the tops and we kept the denominator the same, right? So same thing. Here we have a common denominator of 20. So I'm going to keep the bottom 20 and I'm going to subtract the tops, 11 minus q over 20. Here we got three fractions. So first let's add these first two, 13 plus 5. The denominators are both p, so that's going to stay the same. So there in red you can see I combine 13 over p plus 5 over p to get 18 over p in red. And I left the blue minus 7 over p. I just left it alone for now because we're going to get to that next. And now I'm subtracting fractions. I have a common denominator, so I'm allowed to subtract them. 18 minus 7 on the top, and the denominator stays the same because that's what we do for adding and subtracting fractions. And we get 11 over p, whatever p is. Maybe they tell us sometime later in the question what p is and we plug it in. Maybe we solve for it and plug it in. That's the kind of stuff that's going to happen in those 05 level courses. And in this last one, I have 5 and a sixth plus k over 6. As soon as I have variables, you remember we talked about this last time, as soon as we have variables, mixed numbers make no sense. And so I am going to turn that 5 and a sixth into 31 over 6. 5 times 6 is 30, plus 1 is 31. Now I have two fractions to add that both have the same denominator, so I just add the tops. 31 plus k on the top and 6 on the bottom. So I'll repeat this again, mainly for the 05 students. Mixed numbers, when you have variables in your fractions, do not compute. They just don't work. So when you have variables, you have to go to improper fractions if they come as mixed numbers. So I got matching denominators again. The 10s will stay. I think I go up top, actually. Yep, there we go. So a few more quick examples. The bottoms match. They're both 10. Add the tops. 7 plus 9 is 16. Notice that that fraction can reduce because they're both divisible by 2. 16 divided by 2 is 8. 10 divided by 2 is 5. There is the improper fraction answer, or if it says give your answer as a mixed number, 5 goes into 8 once with 3 left over. So 1 3/5. Here, this one I threw in on purpose. So we have matching denominators, which means we just add the tops and keep the bottom the same. So 3 plus 5 is 8. So we have 8 over 8, which we are going to write simply as 1. You would never leave a fraction as 8 answer as 8 over 8. You would say, oh, that's 1. What does this mean? I think if you think about the pizza, it makes perfect sense. We bought one pizza. We cut it into 8 pieces. I ate 3 of them and you ate 5 of them. How much of the pizza did we eat? We ate the entire one whole pizza. Or maybe we bought 6 pizzas and cut them all into 8 pieces. You ate 3 pieces, I ate 5. We ate 1 pizza. We still have more pizzas left, but we ate 1 whole pizza. Here we got some mixed numbers. I made this one work out nicely, so let's do it with the splitting apart method. I'm going to pull apart the 7 and the 4 and pull apart the 3/5 and the 1/5. 7 minus 4 is 3. 3/5 minus 1/5 is 2/5. And put those back together, we get an answer of 3 2/5. Hi there. I am recording, just so people who have walked in know I'm recording this lesson for a few people who asked if I could because they weren't able to come tonight. And then our last one we're going to try here in this little batch, we have 3 5/11 plus 6 9/11. we're going to pull apart. So the 3 and 5/11 and 6 and 9/11, I'm pulling apart the whole numbers in red and the fractions in blue. I'm going to add the whole numbers together. 3 plus 6 is 9. And I'm going to add the fractions together. 5/11 plus 9/11 is 14/11, because when we add and subtract, the denominator stays the same. I notice that 14 is bigger than 11, so I can't leave it like that. I turn 14/11 into 1 and 3/11, because 11 goes into 14 once with 3 left over. This 1 here is going to join with the 9 to make 10. So my final answer, 10 and 3/11. And that is adding and subtracting fractions when the denominators are the same.